Let's look at interest rates versus interest amounts. When someone uses the word interest, they could be referring to a rate, or they could be referring to an amount that's paid in or out. A rate, something like 3%, usually we say R for rate. Remember, the percent symbol means divide by 100. Here's the divide, and here's the two zeros of the 100. So 3% is really 3 over 100. Or as a decimal, 3/100ths. You can double check that on a calculator. An interest amount is found by multiplying a rate by some dollar amount. Since we're talking about finance, but you can have rates based on other things. So maybe I start with $1,000 and I want to know what 3% of that is. So I would just multiply by the decimal or fraction version of that. And I should find that that is equal to $30. And let's check that on a calculator. So 1,000 times, to double check, I could do 3% by saying 3 divided by 100. Some calculators have a percent key, so if I typed the 3 first and then hit the percent key, it puts an of, which implies multiplication, so then I can put the 1,000 after that. Again, that's useful sometimes, but beware with that for more complicated expressions. Same thing as 1,000 times 3/100ths as a decimal. Spreadsheets can do the same thing. So here I can just, if I want to make the calculation, I would have to do equals first, 1,000 asterisk for times, and then 0.03. Now, better than that, I can do things like type. Usually we use the letter P for principal, the amount we start with, the present amount, and then we can have our rate here, and I could type my $1,000 there. And here I could just type 3% into the spreadsheet, and the spreadsheet recognizes that as the number 3 over 100, but displays it as 3%. And then I can calculate the interest by just making an equation where I multiply those two numbers together. So click on one, asterisk, click on the other. Cool thing about that is if I change the rate to like 5%, it'll update it, or if I change the amount to $300, it'll automatically update those amounts. And let's make that dollars, and because I used that dollar in a formula, it assumed that the result had to be dollars too, which is kind of cool. Spreadsheets are pretty powerful tools for finance, percentages, and interest rates and amounts. Now, often with interest rates, so this could be something like I borrow $1,000 from a friend and I promise to pay him back 3% interest on that. So when I pay him back, I'll give him $1,000 and I'll also give him $30. So the $1,000 I owe him plus the interest I promised. And maybe I pay him back in a month, or maybe I pay him back in a year, maybe he doesn't care. Often an interest rate is tied to time, and typically it's an annual percentage rate. Annual percentage rate is often abbreviated APR. And let's use the 3% again as an annual percentage rate. If I make that the catch, that it's annual, then I have to prorate for time. So the above calculation where I took that principal P times the amount R and calculated the interest, often we put I for interest amount. That's assuming it was 1 year. If I'm assuming that's an APR, annual percentage rate, but usually we state it up front, hey, this is an annual percentage rate, which means that if I pay him back at exactly 1 year, then this is the extra amount I owe him for interest. But if I pay him back earlier, like if I pay him after 1 month, then usually business law, if it was agreed upon that was an annual percentage rate, then typically the common procedure, legal procedure is to say, take that $1,000 times your 3%, and then you prorate for the part of the year that happened. And often we'll do 1/12 for that. Now, there actually is a thing called the Federal Truth in Lending Law, and it has some wiggle room on how to calculate that. So if it was January, then I would do 31 out of 365 days. But businesses, legal connections between businesses and consumers, they can actually use any whole number between 360 up to 365 for the number of days in the year, whatever is convenient for them. And that just kind of depends, and it's usually disclosed about how they do that. I'm going to just choose 1 out of 12 for the part of a year. So again, then since this is an annual percentage rate, I have to include how much time has gone by. The assumption up here is that it was times 1 year. Could be a half a year, in which case I would have 1,000 for the interest amount. I'd have $1,000 times that 3% times 1/2. It could be I don't pay him back for a year and a half, in which case that would be $1,000 times 0.03 times 1.5 years. So here now I'm saying the interest is the principal times the rate times the time. And this idea is what we call simple interest. Now, often simple interest gets added back on, meaning I have this amount P I need to pay back. I also have this interest, and for simplicity, I'm just going to call it PR and assume 1 year has gone by. Another way to think about that is I could factor that P out. And if I factor the P out there, then that's like dividing. P goes into P once, and P goes into PR R times. So I get P times 1 plus R, and you've probably seen that formula before. R would be called our interest rate or growth rate, and the 1 plus R is what we call the multiplier, the growth multiplier. Why? Because I'm simply multiplying it to get some finished amount. Now it's a little different than the multiplication that's going on here, because this gives me principal plus interest. Right? And I don't just owe my friend the 3%, I owe him the $1,000 too. So what do I owe him? Well, I would owe him that $1,000 times 1 plus the 3%, which I could do that addition. Order of operations says you should do that first, right? So that would be 1,000 times 1.03. Let's check that on a calculator. Choose Desmos here. 1,000, times 1.03. So in the end, I owe him $1,030 is what this says. So we're putting the two of them together. Now, that kind of thing is powerful when you have, say, wrong page, a savings account, where every year they give you 3% and they stick that back in the account. And we get to repeat that over and over again. So this thing right here gets repeated, that timesing 1 plus R by whatever we had before. And that's the idea of compound interest. And the way that plays into proration is for just yearly interest, we would just have P times 1 plus R to the number of years that go by. So T is my years there, and R is the APR. But it could be we have to pay out interest monthly or daily or every quarter of a year. So in general, that's that proration of the interest rate. And if you think about it, let's go back a page here. This 3% times the 1/12 could also be written as 3% divided by 12. So I'm prorating for monthly interest. Maybe I only do interest semi-annually. So this one right here would be that 3% times 1/2. You could instead divide by 2. If it was quarterly, every 3 months, quarterly, then I would have my 3%, and the proration would be 4 times a year. Daily would be 365 times a year. So we've got this new thing that can vary as the proration, and we usually call that N, and that's the number of periods we collect or give out interest in a year. And so then the formula becomes P times 1 plus, we get the prorated interest, R over N, and could be 1 or 12 for months or 4 for quarters or 365 for days. And then the power is always the number of times we collect interest, which would be the total periods. And think about yearly, if 5 years went by, that would be 12 times 5 or 60 months that happen. So to figure that out, we always take how many times a year times the number of years. That power is always N times T. And that's the general compound interest formula. So this idea of prorating interest is a legal thing that happens, whether we consider that interest to be a one-time thing, which is simple interest, or we have it repeatedly happening where we collect that interest amount, either owed or to pay out to somebody like a savings account, and that's what we call compound interest. And we're going to be looking at variations of this in this finance chapter.